Welcome, everyone. My name is Casey Wang. I'm a co-PI on the Fabric project. Thank you all for joining us today for the 8th installment in our Mastering Fabric Tips and Tricks webinar series. It'll be led by Shi Yang today. Next slide, please. Before we begin, I would like to share a few housekeeping items. The webinar will include a live question and answer session right following the presentation. Please note that the chat feature for Zoom has been disabled. So if at any point you have a question, please just type it into the Q&A box at the bottom of your screen, and we will answer it during the Q&A session. Finally, this webinar is being recorded, and it will be shared with all the registrants. Next slide, please. We are joined today by one of our presenters, Shi Yang. Dr. Shi Yang is a network research engineer at the Scientific Networking Division, ESNet, of Berkeley Lab. He is currently leading the development of the SENSE orchestration system and the NSF Fabric testbed network control system. His research interests include advanced network architecture, next-generation internet, optical networking, large-scale network testbed and application, network middleware for science workflows, and cloud computing. He is also exploring the quantum communication and networking and advanced wireless networking 5G, 6G areas. Now I'll pass it to Shi to start the presentation.
All right, thank you, Casey. My greetings to you, all the folks from all of time zones. So I'm going straight to the agenda for the presentation. I will talk about some background on the Fabric project and also its global connection, which is a substrate for our federation work, and some introduction about the FabFed architecture and Cloud Connect, and how we use the workflow to create cross-facility, cross-testbed slices. I will give a live demo for the simple scenario of a workflow for federation cross Fabric and CloudLab. And then if we have enough time, we can also show a video demo with narrative on the hybrid cloud workflow with AWS, Fabric, and Google Cloud. Just very briefly on the Fabric itself, we all know that the Fabric was founded by NSF. It's a large, realistic testbed project, which is focused on experimentation-based research on network, cyber infrastructure, middleware, and applications. So many of us have spent our last 7 years to build and expand this massive infrastructure, right? It has been very, very successful. So many our researchers have been working on this on a daily basis to making progress on research, doing experimentations. But then there are increasing demand for more capacity, for more capabilities, and for more features. So one way to accommodate those increasing demands rate is to interconnect this Fabric topology with this global partner resources, right? We have many other testbeds over there and public cloud services. So we really want to actually give user extension of the Fabric slice to reach the external resources, right? So speaking of that, right? So today, previously, a typical Fabric experiment will be run in an isolated manner, right? You have everything on Fabric infrastructure, which is isolated from external networks. So when you want to actually extend your slice to access the external resources using external connection, right? So Fabric does offer several connection services. I think the most popular one is the layer 3 public routing service, typically the FabNet V4 XT or FabNet V6 XT, and which basically works like you're going to assign your specific VMs with some public IP address. Then at the same time, we're going to configure our peering point with Ethernet and Ethernet 2 and BGP border routers to punch some firewall rule holes and lose the SAL, so you can actually get your traffic through, right, to external open world. And another way is to create a dedicated layer 2 connection so you're peering with external facility, which is typically going through so-called facility ports, which we're going to talk about later. And also, we have partnership with Ethernet 2 to leverage the L2S Cloud Connect service, so you can actually also get the connection to public cloud resources. And to how we can actually create and to operate with those external connections. Here we can talk about one unique architectural concept for Fabric, which is a facility port. Facility port is the Fabric data plane port, which is based in one of those external resources. So as a construct which is owned by external users, right? One of our external resources, it actually also have a way to expose to our Fabric users by put such definition inside the SNAS instantiation. So it's basically something you can define as an access point to external in your slice. And then that will be access to external resource owned by other facilities. And also we have some like access control by our control framework administration in the Fabric to give you like a specific permission for those access. So there are actually many facility ports in Fabric. We have been actually expanding this list through many years of collaboration with our partners. So you can look at this list, right? So here this is not a complete list, but it actually covers a lot. Right here, we got ASF clouds. We had one is testbed. We have the National Research Platform, the ASF access, those for HPC or high throughput computing resources. You had those international or national regional research networks and testbeds. It had a lot of research facilities, so on and so forth, right? And also, last but not least, right, we have a special kind of facility ports. Those are the public cloud-facing ports. Through our partner Internet 2, all the edge ports facing those public clouds have become the Fabric facility ports. So if you care about where they are, what they look like, right? So you can go to a Fabric portal and open a web portal site. You can click on the menu, says resources, and then it will be drop down, just say resource overview. You click on that one, scroll down, you can see a full list of all those, like about 150 facility ports available on Fabric. So now, how an average user could use Fabric facility ports and also those external connections? Starting about 4 years ago, right? So a group of us designed the Fabric Federation software extension, FabFed solution, with the goal to provide a software stack so Fabric users can run experiments with so-called tool-based federation across multiple testbeds and providers. I'm going to talk about the ideal tool-based federation in a later slide. And then we want to integrate the external network and cloud resources into a Fabric slice in an automated and orchestrated fashion. So this is also part of research to explore testbed of testbeds paradigm. So in FabFed, right? So what are we federating with? So far we have a support for 2 ASF cloud testbeds, the Chameleon, and the CloudLab. We also federate with Internet 2 L2S and the Layer 2 and Layer 3 services, and also importantly, the Cloud Connect services, which allows us to access all those public cloud. And on FabFed, we currently support 2 public cloud providers, the AWS from Amazon and the GCP from Google. We also federate with the AutoGo Sense testbed, which gave us access to most of those regional and international research education networks. But potentially, we could federate with anyone connected through a Persistent port. So the concept or the term of federation is actually very overloaded term, right? So it's complicated. Generally speaking, we talk about 3 or 4 types of federations. One is connection federation, which is what you do at your physical layer to connect to networks in the layer 2, layer 1, or layer 3. Right? We also talk about the identity federation. So if you have a fabric identity, you can use that to access the external providers' resources, and vice versa. You can use other identity to access fabric, right? So in the fabric project, we have other effort or resources to take care of those 2 levels. So now for FabFed, we really want to focus on how we allocate resources and automate and orchestrate them across the test beds in the workflow. So we have 2 options here. And the first option is we can do so-called API-based federation, right? So not actually requires all the test beds using a common API and a common information model, right? Not going to enforce and maintain the API interworking between those providers. After many years of work and far before Fabric, right? So we end up with a conclusion that doing this approach is too challenging, especially for research community where we have very constrained funding resources and timing, so on and so forth. So it's really too expensive for the research community to do that. And that's why we end up with doing tool-based federation, right? So what that means is that the user tools understand how to talk to multiple APIs individually, and we maintain the separate credentials, separate identities to talk to all those APIs at the same time. And then we use those APIs to allocate resources across many facilities, and then create connections between them, right? So this requires relatively small development. There's no longer-term commitment for to make code maintain the common API. So that means actually your code is more sustainable. There's no need for inter-provider dependency, right? So in the constrained environment, that will be much more practical. That's why we end up with a design for FabFed as a tool-based solution. And so now here is the a breakdown of the FabFed architecture, which explains how this tool-based federation works, right? And so as a tool-based solution, obviously we need to talk to multiple providers and separately, right? So for example, in this this diagram, right? So we have 2 providers here, Fabric and the Chameleon. So we have to have a tool to understand we have separate authentication and authorization with Fabric and with Chameleon. Then we talk to their API endpoints separately, not for one. And secondly, we need to have a way to drive a workflow to allocate the resources across both providers. So so first piece of information we want this tool to render is so-called a workflow definition, which is a high-level abstract language, right? So this is proprietary for FabFed, but it's actually very much like a Terraform. If you are familiar with anything like infrastructure as a code, this is similar, right? So it's simple definition to describe what I want to set up across the facilities and test beds, and then how we want to put them together. And then to run your experiment, you need to actually create the workflow session using the FabFed tool, which renders the workflow definition and create a session context, right? That's where you start to actually talk to individual providers, go through their API, like to create a slice inside Fabric, for example, allocate some VMs, create network, then go to external provider like a Chameleon, create a cloud resources in there, create a network. So that's your session, and then the Fabric tool is going to maintain the session context to match your life cycle of the session. But now another piece of information Fabric tool needs is so-called stitching policy, because you need to figure out, okay, how we can actually take those resources on both ends and put them together, right? How can we stitch them together? So important part of this is the understanding of facility ports. So those are where we have the touch points between those two test beds, right? So the FabFed tool is going to render the information on the facility ports using some what we call the system-defined policies to decide how we can create a workflow with the dependency on that stitching point. Like for example, we understand to create stitching, we can first go to Chameleon to create a network, get a VLAN allocation. Then as a dependency, we go to Fabric to say, hey, here, Chameleon has allocated this network for this port on this VLAN. So you can do something similar on your port on your VLAN. So now we can actually get a stitching happen, right? So such parts can also be overridden by certain user preference, not something we call a user defined policy. All those combined, we create the FabFed workflow session to support your experiment, right? So just a little bit of details on how we do that for Cloud Connect services. So this is very similar. You have the Fabric facility, you have the cloud providers facilities. So the two things together, but under the hood, it's more complicated. So you can look at what we're doing here. So the access to cloud is through our partner network, Internet Tools, L2S. So all the edge ports on L2S network facing clouds, like Amazon, Google, Azure, Oracle clouds, they all be integrated into the Fabric control framework. So those ports became the Fabric facility ports. So now to create the Cloud Connect service, right? So on the left side, we allocate resources from Fabric, like VM storage, so on and so forth. We then create layer 3 VPN to attach those resources on one end. Then on the other end, we get our hook into Internet 2 to actually create the L3 VPN to peer with another L3 VPN instance inside L2S service. So basically two BGP speakers, one on Fabric, one on Internet 2. So now the L2 VPN, L3 VPN on Internet 2 will in turn have its BGP session into the, for example, Amazon cloud using direct connect service. So here you can see, okay, under the hood, there are multiple BGP sessions in the continuous chain from mapped inside Fabric through Internet 2, L2S, then cross the cloud edge into cloud, and then somehow you could attach into the virtual private cloud, for example, in Amazon, right? So the difference here from stitching point of view is like instead of doing layer 2 VPN, in the last example of commanding federation, we are doing the layer 3 VPN. There will be BGP configuration across the border. Okay, so now just some simple explanation of the example workflow declaration, right? So this can be a little bit like an anatomy of what we are talking about for workflow declaration. And this is the simple example of how we define the federation between the Fabric and the CloudLab. And my practice, all those workflow declarations are not complex either, right? So this is actually typical, right? It's simple. Others are simple as well. So this is Terraform as I said before, right? So if you're familiar with any infrastructure as code solutions, you can say pretty much the same, right? It's the declarative. You can say some variable defined, which is going to be referenced in the later statements as common parameters. And then we have a list of providers here, right, which actually refer to credential files. That's where you store the individual identity credentials for all those providers. So here we can say we have CloudLab, we have Fabric. They are what we call the infrastructure providers, which create nodes, networks, right, on the infrastructure. We also have something called the genders, which we consider as a service provider, which is going to put the middleware layer, normally the software containers on top of the infrastructure substrate. I'm going to talk about this service provider later. So now on the right side, you can see a structure of the federated resources. You can consider this as one slice extend across multiple facilities. So again, on top there's some common statements in the config section, but now in the resource part, right? So the network section, we define one network CNI, which is a variable inside CloudLab, which refers to the CloudLab provider we define here. And then we define another network, which is referred to the Fabric provider, where we consider that as a network we place inside the Fabric. So each of them have their individual like a profile. Like for example, CloudLab using FabFed test scalable CloudLab a hint on what type of network service you want to create there. So now we also want to create the computer node on both sides, right? So one node on CloudLab, again with reference to a CloudLab provider, one node on Fabric with reference to Fabric provider, and with some parameters like images or model, so on and so forth, right? So we also said each node will be attached to the corresponding network statements. So now with those nodes and networks, here we define our stitching policy. So we are saying the Fabric network should stitch with the CloudLab network, right? So that's how we have our typology here. By the way, here's a typo here. There should be net. Okay, so besides this, like default stitching, user can have some preference, right? So if I'm going to show you in our lab demo, but normally your FabFed is going to pick the stitching point for you, but the user can put in some preference. So for example, in this case, the user will say, okay, I prefer to stitch in the Clemson, right? So not can be user preference. So with all this together, it's going to be able to describe infrastructure layer resource allocation with two nodes and across two facilities, stitching in the middle, right? So that's what this is about. And then finally, there will be a service layer of resource. Actually, I'm going to talk about this in my live demo, but essentially it's going to be a mini orchestrator just instantiated on top of those node networks to distribute a bunch of containers across the created resources to run a network and performance test. That's a service layer. So there'll be more details being covered in a later demonstration. So last but not least is the FabFed tooling. So we said the FabFed is going to take input from the workflow declaration, then take input from staging policy declaration by render those, and then create the workflow across multiple test beds, right? Then the tools we're offering, first of all, so you can actually download a Python package for FabFed. And so those are already in place. I can show you in the later demonstration how we do that. From there, there's two flavors of FabFed tooling for you to actually create your experiment. You can use your command terminal. You can do. We have the coming with this Python package. There's a workflow API CI tool, right? You can use that to drive your workflow, render the policy, render the declaration, and maintain your session context. Or we also have a flavor of FabFed using Jupyter Notebook, and that's what I'm going to demonstrate right now. So the second part of my presentation is the lab demo for FabFed using Jupyter Notebook. So in the simple scenario, I'm going to demonstrate how we can do FabFed across Fabric testbed and CloudLab and testbed. Okay, so let me actually jump over to the Jupyter Notebook. Okay, so 1 second. So this Jupyter Notebook, I have already. Give me 1 second. Okay. Okay. So if you're on this Jupyter Notebook, if you go to any of those distributions, and you typically come this comment start here page, so you can actually go scroll down to the complex recipes section, right? So you can click on the workflow, the FabFed workflow tool, right? So there's some introduction here, but what it really does is actually pretty simple. It just redirects you to the artifact manager page. So you go here, you can run the artifact manager to set up list of all those artifacts we have on Fabric. So just wait here. Okay. So now at this window, I just search for FabFed, and you can just download that. Right. So now once that's downloaded into your local Jupyter Hub directory, you just click to get your the root level of your folders, right? So here you can say the downloaded directory on the FabFed examples. Just click in there. So this is the version of the FabFed for this artifact. Click in. You can say one table and plus one already extracted. This automatic extracted examples folder. Click in there. Now we have the structure of our tools, right, and plus some examples. So here, the welcome page, again, this is a FabFed welcome page. You come here. So your first thing you do is you can use this page to install the FabFed package plus some tools for like dependencies tools for working with other test beds. So normally you don't need this, but for CloudLab, we do need actually additional installation, which is not included in the FabFed. For all other test beds, everything already included. Okay, so I have already installed this just minutes before my presentation. So I'm going to skip the first part because it's going to take a few minutes. So I just want to verify this one is already installed. Right? Okay, yeah, that's says the commands already in my environment. So the FabFed and FabFed workflow, those are the tools we can use. If I run this from terminal, right? This is going to be the tool you can use. And today I'm going to walk this through on the Jupyter notebook, right? So proceed with this demonstration. The first thing, if you are a beginner on this FabFed, right? So first thing you want to do is to configure your credentials file. So that's going to get you access to all the testbed providers API, right? So we're going to first of all we're going to do a script to that's going to actually copy the template from the distribution into a dedicated like a location for this profile. Then second thing you do is you're going to so this is what we do for Fabric only. It's just for some convenience on this Jupyter notebook. So we create a script which extract the information from your local Jupyter notebook environment that give you a section of a configuration for your credentials and authentication just for Fabric provider. So we're gonna let me copy this. I'm gonna then show you how we want to use this. So now going proceed with that, we're gonna open up our credentials file. Look at here. So this is a template credential file which has been copied into our the configuration folder. So that it has an empty configuration for all the providers we currently support, right? So for today, we're going to copy over the generated Fabric credential we already put in there. And because we're also doing the CloudLab, right? So I'm also going to copy some CloudLab credential. So just to save our time, I already have some configuration I saved there, so I just copy over. So that will link to some of my private keys and user credentials already put on the GitHub environment, right? So now we have a credentials file being defined with two providers authentication mechanisms in the credentials file. So I can close it up. And if you go through this like notebook plus documentation, you can see some details about how we want to actually adjust some environment variables, which we don't have to do right now. And then we can go straight to our demonstration. So we provide many examples of different kind of scenarios, how you stitch to CloudLab, how you stitch to Chameleon, how to stitch to Google Cloud or Amazon Cloud, or plus how you stitch a couple of clouds together, right? Some more advanced stitching scenarios. Since we don't have not much time today, so we just focus on the Fabric plus CloudLab scenario. So click on this one. Let's give you an example for stitching between CloudLab and Fabric, right? So here, just follow through this example. You can see first command you can run is to reveal the stitching policy between CloudLab and Fabric. This is the system-defined stitching policy, which comes from your Python package distribution. So if you run a command, you can just confirm, okay, we do have a default stitching policy already configured between CloudLab and Fabric, which tells you, okay, which ports or which processor ports, right, the stitching could happen. And when you go those ports, right, so what are the range of parameters you could use, so on and so forth. Those are already being built into our Fabric control framework. We just query this as we go, right? So there are two options to the stitching. And if a net system to pick, it's probably likely to pick the first one, right? Or you can override that. So now we proceed with the set up our like our slides, right? So let's name our session and let's call that demo. Use today's date is 0A19, right? Let's do that. So that will actually give us a session name here. The session is the unique context for your current experiment. So we will run that. That's going to actually those scripts help you to actually create all those files you need for your. But if you want to make it simple, right? Normally you don't need to those complex stuff. You just need to go open those files manually to do inspection. For example, you can open this FabFed workflow declaration file, which is almost exactly the same as I already showed you in that workflow declaration anatomy slide, right? So we want to create nodes, networks, and stitching them across two test beds. Plus, we want to put the channels service layer on top. By the way, if we want to do that, we need to actually make this from default 0 to 1, which means we do want to have a channel service to be instantiated on top. So once we are done with this, we save the file, then we proceed with our stitching workflow. So once you have this stitching declaration, right? So if you create this on your own, first thing you want to do is to a validation, which is basically a syntax check. Make sure you're not actually typing anything wrong or any keyword wrong. And then you could also use this workflow -plan command to verify, okay, semantically. Oops, I think I did something wrong here.
It says that you need something, expecting a value for project. You don't have a project in your credential file for CloudLab, looks like.
Yeah, I'm looking down. Let me double check if I actually forget something here. Let's see. It's very quick here. Miss something here. How's your file?
No, the CloudLab.
Oh, hold on. CloudLab.
Oh, you have everything. So
Okay. Maybe did I save this? Let me try it again. Let's try it again. Oh, this works every time in the last 10 days. I'm not sure. And you know what? I'm gonna start over on this whole thing.
okay.
Yeah, I'm going to destroy this. And maybe I should just delete this whole thing, start over.
Yeah.
Okay, let me do that. Sorry about that. I think I was doing some preparation, which I might should delete some stuff accidentally. Should I just do a whole remove?
Sure.
And that requires me to cancel this.
Hmm.
Do this very quickly. Let's see. Is it safe to delete the whole thing, or just delete examples underneath? Re-download this. Okay, let's start over. And you know what? Let's totally start over. Sorry about the folks. We have to probably do this totally start over. Sounds it has been.
Oh man. Oh, you're starting the whole server?
Yeah, I think messed with some artifact. We actually delay our demonstration probably by 5 minutes, but I can guarantee we have a clean slate environment to run through. Because normally that's how we do. So we always do it from clean slate. Okay, so here we go. Yeah, we can go to my artifact directly to here. Okay, there we go. Let's do this very quick. Now I have to go through this painful process of install this. Hopefully it can be done in 2 minutes. Yeah, while we're waiting, just want to explain very quickly. So yeah, as already said, all the packages are already included in the FabFed for access to other providers, including the clouds, including the Chameleon fabric itself. The only exception is the CloudLab, which I do not have a package to usually do that. So we have downloaded from a separate process, so we can verify that's there. Okay, good. So we can actually jump all the way here to the end of, but I still have to create this link. So we jump here and create this. Okay, we can do the collab. Okay, save. Okay, now
Can you go back to the credential file, please? The CloudLab section.
Yeah.
Just make sure there is no funny character or anything. Is there anything funny?
Yeah. It should not be.
It looks good, but
yeah. Okay. Yeah, that's what I do. I did this like more than 10 times. Never had the problem.
Okay.
Anyways, it's always something with demo. So okay, so let's just do this again, right? And then we're going to do this again. So make sure we got this to set to 1, so we can actually do this in one shot. So everything included, and validate the file definition. We do the planning. Okay, here we go. Okay, so now we're back to business. So now this those are some like auxiliary and commands basically help us to actually examine the workflow definition. Like this one is called -plan, right? The plan command is going to look through your the definition, right? It's basically to tell you, okay, definition to tell you, okay, what type of resources and what number of resources we are creating. Tells you, okay, here you're going to create one network on Fabric, one network on CloudLab, one node on Chameleon, one node CloudLab, one node Fabric, and one service for DTN service on top, right? So that's what it does. Also, there's a command for checking the stitching policy. So that one will tell you where it decide to make stitching happen. You can validate your preference here. We did say instead of using the default one, want to stitch the Chameleon, right? So that actually give you the Chameleon stitching policy, so which actually confirms what we want. Also importantly, it does give you the workflow like decision on who is going to be the producer and consumer on that stitching. So the concept of producer versus consumer means we're going to go to Fabric first to allocate the stitching resource, like which VLAN, which port, which VLAN application we're going to get on Fabric. And then on the CloudLab side, we can just to feed that information to CloudLab to tell CloudLab, okay, just consume not the stitching parameters to create your stitching purity resource, right? So that determines the order, the dependencies in the stitching workflow. All right, so now we can we verify those information. We can go ahead to our stitching FabFed workflow session, right? So this is very similar to, if I'm familiar with something like a Kubernetes deployment, right? So it's very similar. You should use a -apply command to render this Terraform like config file. It's going to go through the process of first thing, because Fabric is a producer. You can say it goes first. It goes to Fabric to contact Fabric provider through a Fabric control framework API to get the services to be created there. You can say that's the result comes from back from Fabric control framework tells okay what resources have been allocated on Fabric, and there's a lot of details about node also stitching resource, like here Fabric said I'm going to VLAN number 3984 on the Chameleon facility port, and that's the stitching parameter Fabric picks for that policy. Now will be further fed to the consumer side, which is the CloudLab, and to make a stitching happen. So once the Fabric is done those, right? So now we are in the CloudLab territory, right? So it starts with talk to CloudLab API and make the CloudLab resource allocation happening here. Right? So that's ongoing. It might take a few minutes, but then we can get both network and the computer host on CloudLab, right? So okay, yeah, let's just keep on going for a little bit. Yeah, getting back to our workflow definition, right? So if you want to other scenarios, like if you have Chameleon, or if you have like a cloud, so things will be very similar, right? So it's the main difference obviously will be some specific integrants you want to put on each facility, like on this facility you want GPU instead of a CPU, right? So on the other one, you want actually a specific network profile instead of default one, right? And also like for this specific workflow definition, and the stitching happen at layer 2, right? So we just showed the VLAN stitching. Like you have allocated one VLAN on one side, then use the same VLAN on the other side, which is a layer 2 VPN connection. So then we put the layer 3 subnet on top. So we have a node on one end and another node on the other end in CloudLab. So we put and the IP address as a sublet on both sides. We make sure they are using the same layer 3 configuration. So we will end up with allocate the layer 3 address on one end of a CloudLab node, then another IPv4 address from the same subnet on the other end of a Fabric node. Another way, over this layer 2 VPN, we have two addresses we can talk to each other, right? So that's how this whole thing is configured. And now let's say we are finished with, yeah, here we go. So we are finished with this Fabric plus CloudLab provisioning. You could say some of those like messages. Yeah, I think those a lot of those things actually we have built in like a resilience there. So yeah, if those things, then this workflow is kept going. So yeah, don't freak out. Just wait for it to finish, because sometimes it will make some check, and then you'll work around some failures. So and just retry. So those are fine. Just keep going. Right. So here we had our final confirmation. Like we have two nodes, one on Cloud node and CloudLab side, one on Fabric side. Both are existing. Those are the addresses we allocate out of that /24 subnet, and we both have passed pin test, which means they are good, right? So now we are done actually with this so-called infrastructure layer of provider operations. Now we have VMs across both infrastructures. We have networks which are stitching together. So now what I'm doing is we're putting on top what we call the service provider. So here I can explain a bit more, because we will probably have to wait for a few more minutes for this service provider to finish. So what service provider means is a lot of times, right? So if you're doing experiments, it's not enough to just have VMs or networks, right? So you want to actually put some middleware on top so you can instrument the experiments. That's what we call a service provider, right? So it's one type of service provider. We can have more flavors, which is just a way to create the necessary middleware and software on top of the infrastructure layer, so you can actually use that to support your experiment. So the example here is for channels, which is the ESNet product. So what it does is this is the special purpose container orchestrator. So when we deploy this on the substrate of this infrastructure here, it will put a dedicated controller container, then put a bunch of agent container across all those hosts, and that will help to create a distributed cluster of orchestrators across the whole infrastructure. I mean, this is the OLE infrastructure. And so you can think of this as a mini Kubernetes cluster, but it's not Kubernetes based. So there are some built-in images you can leverage to typically to run network performance tests and do data movement tests, so on and so forth. Right? So this is a purpose built orchestrator for containers on top, just for network experiments. So with this being built on top of the infrastructures, we wait for this to be finished. Actually, you can say how much. Oops, I think I did something wrong here. I forgot to, when I need the, my mistake I did is I forgot to change the permission of the SSH key, but not to open. I believe what's happening here. Yeah, it's bad. I need to make this. Okay, it's not a bit better, but to fix the problem, we probably have to run this again. Otherwise, okay, I think I'm running out of time, so I'm probably going to leave this as is. I just show you very quickly. So it's according to the FabFed workflow. This is finished, right? So we have interface with two networks, two nodes, and one service on top, right? So then you can run the summary, and you can actually see all those information for your nodes networks plus the service on top. You can do the channel search will give a manifest saying if you do this SH tunnel for your channels controller, which is just dynamically built here, then you should be able to run the controller portal, which is also just created on the fly. Get in there, you can navigate through all those and like resources, and like because of not the SH key error, now I can only access one node. Right, in theory, we should also access the other end of this node of this slash, which is the CloudLab node. And so now we can actually use this to run some network test sessions across both nodes. And I think I'm running out of time here, so I'm not going to
But it's worth noting that yes, if you hit apply, you can just keep hitting apply until it converges to the
yeah. Once I just fixed that, so this is very much like the Kubernetes, right? So if you fix stuff, if you apply again, it's going to fix that automatically. But because I'm running out of time, so I'm going to skip that. And also because some hiccup with earlier demo, so I'm not going to go through the final part of this this slide, which is a video demo for the scenario which we do so-called hybrid cloud. We have the computer resource inside Amazon, inside Google, inside the Fabric. Then we do a three-way like a stitching connection, so we can create a triangle topology to stitch between resource inside Amazon, resource inside Google, resource inside Fabric, and put all those together. So I have I plan to actually show the video demo here, but since I'm running out of time, so this slide will be shared, the video will be published, and also you can scan this QR code. You should be able to see this 6 minutes so demonstration show how you can also use FabFed to do public cloud or hybrid cloud services. And we can only do video here just because going through our process would be like something like 20 minutes, will be too long for our live demo. Okay, so okay, that's all for today's presentation here, and I would have some time for Q&A.
Yeah, thank you very much, Xi. We'll now get started into the Q&A session. And in addition to Xi, we also have Abdelaila Essiari, who's a colleague with Xi, to join us in the Q&A. Now we'll begin with some questions submitted during the presentation. And Xi, you can feel free to stop your screen share. The first question, the workflow you shared seems thorough, but also difficult for users to write. Can you share any user experiences around this? For example, how difficult is it to write correctly, and how can one debug the workflows?
Right. So yeah, I know. I mean, there's sometimes there's no simple answer to complex questions, right? So I'm talking about questions of the federation across multiple facilities. So what I'm trying to do here is actually trying to provide a lot of examples, right? I think that's actually in line with the design of a Jupyter Notebook Fabric portal. So instead of ask users to write stuff from scratch, right, to teach your schema, write everything from scratch, we provide a very rich set of examples how you typically do between Fabric and CloudLab, and between Fabric and Chameleon, across clouds, and so forth. So you can take those, most of those examples can be used as is, right? For your purpose, you can modify some resource integrants, like how many VMs you want to get, how many networks you want to get, so on and so forth, images, so on and so forth, right? So, but if you want to do more sophisticated ones, I believe much of the work will be just copy paste. You can pretty much take those chunks of stuff, assemble them together. I think once you have that, you can use that again and again or you can just share with others as well.
Thank you. That's great. The second question, can FabFed support a new testbed? So in addition to the one that's already there, how would a new testbed work with Fabric and other testbeds through FabFed?
Right. So the Fabric can absolutely support new testbed. Not exactly what this is designed for. Right? So FabFed has the pluggable framework. Which means you can just join some new piece of code called a provider plugin. Not just say you have a new wireless network testbed, which has its special API and different ways to do credential and authentication. That can be built into an additional provider plugin. You need maybe the development, but not huge, to put that into FabFed, and then we can figure out some maybe additional schema for special integrants, right? How do you want to represent, for example, a base station or antenna on your testbed, for example, right? So those can be added in there. But once those are in place, that can be integrated into the workflow of a FabFed. I think that's just requires a special treatment of another provider for authentication and for API interactions.
Sure, thank you. Question 3, does FabFed support federated identity?
And so, yeah, so FabFed in design, right? So we call it tool-based solution. Not really means it's actually made assumption we can treat those identities separately for individual testbed providers. So if we do have like multiple testbeds use federated identity, like for example, if two testbeds are both using the cellular ground token, right? So we can absolutely just do the same type of authentication with each. But the overall workflow will still be the same. We are still going to walk through the cross them, talk to them individually on the individual APIs. We can just happen to be using the same credential.
That's great. The next question, what is the resource authorization policy on FabFed?
So again, FabFed is the tool-based solution. What that means is actually besides authentication, it also does authentication separately with its providers. So we do not define like a ecosystem-wide policy or resource policy per se, right? So as a user, you have to associate your specific identity with your specific provider and negotiate your specific policies with those providers. So in that sense, it's already tied to the per provider identity for policy control. So we don't not mean enforcing the policy across all those testbeds is also very hard because we do not really have a common language to define those things. So that's where we're really being up to users to negotiate their individual provider policies.
Thank you. The next question, are NRP sites available through FabFed?
Yes and no. So NRP itself, my understanding is it's a Kubernetes-based platform. So if we were talking about the native like a NRP provider API, we currently do not support that yet. We do have a discussion, maybe even like a rough plan to do that. So that means we can go to Kubernetes API to set up resources on NRP. But on the other hand, some of those NRP sites, they allocate resources for example, to other test beds, like on AutoGo test bed, we have some presence on some NRP sites where we can leverage the sense controller or sense orchestrator to allocate NRP resources. So we do have a provider through the sense AutoGo test bed where we can actually help to secure some resources from NRP as well.
Thank you. The next question, how fast can FabFed create an experiment across multiple test beds?
It depends. So normally a FabFed works as a chain of actions, right? So it's a workflow. So there's dependency across different test beds providers. So we normally do one first, and then because we're talking about the idea of like a stitching consumer versus a producer. So producer goes first, consumer goes next. But instead of doing completely being sequential, so our recent version of FabFed does some parallelization or async optimization. So that means actually certain actions we don't have to wait. As we know what happens on the stitching part, everything else can be parallelized. So for example, for fabric to CloudLab federation, we used to need at least 15 minutes to create one size class. So now we need probably like 5 to 6 minutes. That's big improvement. But there are certain providers like those cloud providers like Amazon, Google. Those are completely out of our control. So like typically you can expect you set up a resource on Amazon or Google. It takes anywhere between 5 minutes and 20 minutes or even more.
Mm-hmm. Great. Now the last question I have here, how can I contribute to the FabFed open source?
Yeah, so yeah, Fabric, first of all, I mean, whole Fabric project is open source, so is FabFed, which is just a sub-component of a Fabric control framework. So it's open source, and also our repository is under Fabric testbed / FabFed. It's an open repository. So everybody is welcome to use the code, review the code. You can create a fork, and you can modify it. You can create your own provider plugin if you want to adapt with your own providers. And if you not touch it, contribute your code back to the main upstream. Yeah, so yeah, please talk to us or anyone in the Fabric team. So we'll be happy to work with you to absorb some of your contribution.
Sure. And with that, thank you again for our presenter Shi Yang and our guest Abdullah Essiari. We'll also, in addition to our presenters, like to acknowledge a team behind the scenes who have been working diligently to bring this webinar to the production. Can we go on to the next slide? So as you can see, myself, Chelsea, and Jayshree were on the Fabric team producing these webinars. And the next slide. Thank you to the audience for your participation in today's webinar. So in addition to the recording of the webinar, we will also email everyone with a list of resources. The slide deck will be shared, and there should be a Connect with Us form you can find in the slide deck. We hope that you will reach out to Fabric team for more questions and for support. Next slide. Our webinar next month will be on September 16 at 3 p.m. Eastern Time. It will be the Stitching Together Innovation with Fabric Users webinar. The webinar will be focused on new users, so we would appreciate it if you can forward this information to relevant users in your communities. In addition, our 11th knit workshop will take place in Salt Lake City, Utah. It will be on October 14 to 15, and the registration site is already open. You can find it on the Fabric website. And finally, please submit your Fabric matrix if you're a current Fabric user. And make sure your project description in the portal is up to date, because we do like to use that information to promote your work and for outreach, and including showing some of those contents on our website. With that, thank you all again and have a wonderful day.